Hey guys, today we're starting a new topic, 1.6, polynomial functions and end behavior. Okay, so end behavior of a function describes how the function behaves, so behavior, as it moves infinitely to the left or the right. So those are the two ends of the graph, the left and the right, and we just want to know how it behaves. So in other words, what we're looking for is what happens to the y values as x either increases or decreases. So what that's referring to is if you look at the x's, if I'm looking at the left side, they get more and more negative. So that's the decreasing, so left. And then for increasing, it's right. So what I did is I wrote down in words what each thing means, and then I wrote down some notation. So if we're talking about the left, that means as x decreases without bound, your teachers before this class might have used this notation. X with an arrow negative infinity. For the right, this time the x is increasing without bound, so then x is approaching positive infinity. If the function is pointing down, this time we have to use f of x, so now the function decreasing without bound, f of x is going towards negative infinity, and if it's going up, f of x is increasing without bound, x is going towards positive infinity. So this is the direction, what you would see in words, and then just like notation for it. But what we're going to do in our class is we're not really going to use this shorthand anymore. What we're going to do is a limit statement. So I created a little table here so that we can write what these limit statements would look like. So in this table, we're going to talk about the left side and the right side of the graph. And then we're going to talk about how do we write it when it's pointing down and how do we write it when it's pointing up. So let's start at this top left. If I'm looking at the left side of my graph and I want to write it as a limit, what we do is we write the word lim. So instead of writing the whole word limit, just the word lim. And underneath, x arrow negative infinity. Because we know from before that anytime you see this, that means the left side of the graph. But now I want to say that the function is pointing down. So for down, usually we say f of x with an arrow and then negative infinity. So next to this lim, you're going to write f of x, but instead of arrow, you're going to do equals negative infinity. Okay, underneath this, so I still want to talk about the left side of the graph, so the limit as x arrow negative infinity, but now I want to say that the function is pointing up. So we're going to say the function equals positive infinity. So I'm not writing the plus sign, we just know that it's positive if I don't write negative. Okay, then for the right side, the limit as x approaches infinity. So notice over here for left there's a negative, but on the right it's positive. But I want to say my function is pointing down, so negative infinity. And then the limit as x arrow infinity, f of x equals infinity. So when you look at this table, it honestly kind of looks like I wrote the same thing 4 times, but I promise that they are different. It's subtle differences though. So for the left, make sure that x is negative. For the right, make sure that these x's are going towards positive. If it's pointing down, then it needs to equal negative infinity. If it's pointing up, then it needs to equal positive infinity. So those are the 4 different options that you might have to write. So for our examples, and you should have picked up these graphs on the way in, describe the end behavior of each graph using limits. So that slip of paper, these graphs are in order. So it's just the one on the left and then the one on the right. There should be scissors and tape in the baskets for every single desk. So you can cut those out and tape them in now. So let's look at the one on the left, so letter A, and I'm actually going to call this one, since it doesn't have a name, say I were to call this one f of x. I want to describe what's happening on the ends. So when I look at the left side, so there's the left side, it's pointing down. So I'm going to put L for left, that way we don't get confused. The limit as x goes towards negative infinity. So see how those x's are getting smaller and smaller? The function, so f of x, is going down. So the y values are getting smaller and smaller, so negative infinity. Okay, and then for the right side, the limit as x goes towards positive infinity. So again, look at those x's, they're getting bigger and bigger. F of x equals, so when I look on the right side, this graph is pointing up. So positive infinity. That's what describes the end behavior of that graph. Okay, and then for part B, but I'm going to call it g of x. We need to say the left side and the right side. For the left, we're going to have limit as x approaches negative infinity. But on this one, both sides are pointing down. So I'm going to say g of x equals negative infinity. Then for the right, the limit as x goes towards positive infinity of g of x equals negative infinity. So left is negative x, right is positive x, but since both sides were pointing down, both of these are negative. Okay, so then example 2, I kind of want to do the opposite. So draw a graph with the given end behavior. So on that slip of paper, you should have two sets of limit statements. There's one that has an f of x, and then there's one that has a g of x. So what we're going to do is draw a graph to match that behavior. So just underneath it, I'm going to do a graph here. And then same thing for the other one. Okay, and let's take a closer look at these limits. So when you look at these limits, there's two things to look at. So first you look at the x part. So if it says x is going towards negative infinity, I know that that means the left side. And then look at this part. This is a positive infinity, so that means that the left has to be pointing up. Okay, and then the limit below it, x is going towards positive infinity, so that's the right. F of x equals positive infinity, so it's pointing up. So on this one, we need a function where both sides are pointing up. So it could be a parabola, it could be something with like wiggles in it. Just to make it look kind of fancy, I'm going to do something with wiggles in it. So say something like this. Both sides are pointing up. Okay, and then for part B, this time it's g of x. Again, take a close look at those x's. So the top one is negative and the bottom one is positive, so I know that's left and right. And then g of x is positive infinity, so the left needs to point up. And then over here, g of x is negative infinity, so the right needs to point down. So on this one, it could be a line, honestly, but I'm going to do, let's say, like a cubic function, something like this. So the left is pointing up and the right is pointing down. Okay, so with graphs are pictures, so we can see exactly what's going on. But we also need to be able to figure out end behavior just by looking at equations. So we're going to do an example of that, but before we do, another little organizational table. This is called the leading coefficient test. If you have something that has an even degree, so remember degree is the highest exponent, both ends are going to point the same direction. If it's odd, both ends are going to go different directions. Then the leading coefficient, so I put plus LC if it's positive, and then LC negative if it's negative. Okay, so let's look at that table. If it is even, I know that they both have to go the same direction, but if the leading coefficient is positive, that means that both sides are actually going to point up. Again, if it's even, so they have to go same, but this time it's negative, both sides have to point down. If it's odd, they have to be different, so it's going to be one up, one down. But if it's positive, it needs to start low. That way it has room to like actually get bigger. So the left is going to be down and the right's going to be up. And then if it's negative, it has to start on the top and then get lower. Okay, so for example 3, I have 3 functions written out. First, we're going to identify degree and leading coefficient, and then we're going to write limit statements for the end behavior. So that first one, part A, f of x equals 2x to the third minus 5x plus 1. So look for the highest exponent. So that looks like the third power there. That's going to be the degree. And 3 is an odd number. Then our leading coefficient is the coefficient in front of that, 2. But that's a positive number. So I want to know what happens if it's odd and positive. So here's odd, positive. This is what's going to happen to that graph. The left side is going to point down and the right side is going to point up. So the limit as x approaches negative infinity of f of x is negative infinity. And the limit as x approaches positive infinity of f of x is positive infinity. This is saying left is down, and this one is saying is the right pointing up. Okay, then this one, part B, g of x equals 7x squared minus 4x cubed. Look for the biggest exponent, so it's that 3. So this is our leading term. Degree is 3, which again is an odd number. But its leading coefficient is negative 4, so that's negative. So if it's odd and negative, here's odd, here's negative, this is the behavior we need to do. So left side up, right side down. The limit as x goes towards negative infinity of g of x is going to go up, so positive infinity. And then the limit as x goes towards positive infinity of g of x needs to go down, so negative infinity. And then last one, I actually want to change this a little bit. So h of x equals x squared. So biggest exponent is obviously that 2, which is an even number. And then leading coefficient, if we don't see anything, then it's an invisible 1 in front. So that's positive. So if it's even and positive, so even, positive, both sides are going to point up. So the limit as x goes towards negative infinity, that represents the left, of h of x is infinity, so left is going up. And then the limit as x goes towards positive infinity, that means the right side, is also going up. Okay, and that's everything that we need to know about end behavior. So I know I went a little bit fast, but you could always rewind, fast forward, pause, do everything. You have your little slips of paper where you can tape in your examples. Just make sure that your notes are all filled in, and tomorrow we're going to have practice over this concept.